The universe was once a dark, empty void without life or light. Then suddenly everything we know burst into existence in a single moment. For the longest time, no one could really explain how or show us what it was like back then. But that's changed now. The James Webb Telescope has achieved a monumental scientific milestone by giving humanity its first ever glimpse at those ancient times. Join us in exploring the image that will make us rethink everything. Before the Big Bang, what came before space and time? In a time when we thought we knew everything about the cosmos, the James Webb Space Telescope has shown us something entirely unexpected. It's like finding a new puzzle when we thought we were close to solving the old one, making us rethink what we believed about how the universe started. The latest findings from the James Webb Space Telescope have turned our understanding of the cosmos on its head, making us question our previous beliefs about the Big Bang's origins. What mysteries does the universe still hold from us? What happened before the concept of time as we know it began? With the James Webb Space Telescope, we're on the verge of discovering answers to these fascinating questions. Let's dive into the James Webb Space Telescope's groundbreaking insights into what occurred before the Big Bang. You might think you understand the Big Bang theory, but the recent discoveries from the James Webb Space Telescope have uncovered new layers of cosmic history, revealing insights into what happened before that defining moment. To truly grasp the significance of these findings, we need to take a step back and look again at our understanding of the Big Bang, the event believed to be the start of our cosmic story. Scientists have long theorized that the universe began from a point of incredibly concentrated, intense energy. Imagine this point as a tiny dot filled with the universe's potential energy. Suddenly, this dot started expanding rapidly, unfolding space and time, creating galaxies, stars, planets, and everything we see in the cosmos today. This burst of expansion is thought to be the beginning of everything in the universe. Evidence supporting this event comes from various observations, most notably Hubble's law, which shows that galaxies are moving away from us, indicating they were once close together in that dense point. However, this is just the beginning of the story. Other evidence, like the cosmic microwave background radiation, a type of energy left from the early universe, the existence of ancient elements, and how galaxies have grown and spread, gives us clues about the universe's early days. Yet the question of what exactly happened before the Big Bang triggered everything remains a mystery. This question has puzzled scientists for years and may hold the key to understanding where everything we see comes from. The Big Bang theory explains a lot about how the universe might have started with a massive explosion, but it doesn't tell us what caused the explosion or what was happening before it. In the vast field of cosmic exploration, numerous theories and ideas have been proposed by intelligent minds trying to fill the gaps in our understanding of the universe. These individuals, driven by curiosity and the pursuit for knowledge, are exploring the mysteries of the cosmos, using new ideas and groundbreaking theories to put together the cosmic puzzle. One interesting theory is the Big Bounce. This concept goes beyond the usual scope of discussion. It's a scientific hypothesis suggesting the universe is part of an endless cycle of expansion and contraction. Picture a previous universe, similar to ours, gradually getting smaller and more compact until it reached an extremely dense state known as a singularity. But this singularity isn't the end of the story. Instead, this highly condensed point goes through a dramatic change, exploding outward and creating a new universe, which might be the one we live in today. The Big Bounce theory has intrigued scientists for a while, but it has only recently started to gain more attention among scientists and researchers. They're considering the possibility that this cycle of transitioning from one universe to another could be influenced by different factors. One potential factor is the strange behavior of tiny particles studied in quantum processes. These particles can behave in unexpected ways, and some theorists think these quantum behaviors could be crucial in triggering the cosmic bounce from one universe to the next. Another possible factor is gravity, a force we all know but still contains many mysteries, especially concerning its role in the cosmos. The oddities of gravitational forces, especially in extreme conditions like those at a singularity, might help us understand how a universe can collapse and then explode into existence again. The theory of extra dimensions, worlds beyond our three-dimensional perception, could also be crucial to the Big Bounce theory. These hidden dimensions, which we cannot see or understand, might significantly influence how a universe is born, introducing new laws of physics that manage the transition from one cosmic cycle to another. This exploration into the Big Bounce theory opens up an exciting discussion about the nature of our universe and where it might have come from. Another fascinating idea is the ekpyrotic scenario, which sounds like something out of a science fiction book. Instead of thinking of our universe as standing alone, imagine it as one of two huge thin sheets or membranes floating in a higher dimensional space. These are not ordinary sheets. In physics, we call them brons, short for membranes. These branes move through this extra-dimensional space, which is beyond our usual understanding of space. Imagine our universe, one of these branes, drifting through this vast, unseen space. Then it suddenly collides with another brane. This collision isn't just a small bump, but a huge cosmic crash of incredible scale and energy. This massive event is what some scientists think might have started what we call inflation, a rapid expansion of the early universe that stretched it out, making it smoother and more uniform. According to this theory, this dramatic collision between brons could be the event that began our universe. But it gets even more interesting. This isn't seen as a one-time event. The ekpyrotic scenario suggests that these branes, these huge cosmic sheets, might periodically collide with each other. Each collision isn't just a massive cosmic event, but a moment when a new universe is born. Imagine what this means: a process where universes are born, evolve, and then set the stage for new universes to emerge from their cosmic collisions. Now let's look closer into the universe's story, finding ideas that make us think big and imagine more. The universe's first big changes. In our ongoing exploration of the universe's mysteries, we encounter another intriguing concept known as the pre-Big Bang scenario. This theory introduces the idea that the universe we live in began from a very different state than we see today. Originally, it was in a phase where there was very little energy, but a lot of bending and twisting in space. Imagine a tightly coiled spring. That's kind of what the early universe might have looked like in terms of its shape and energy. According to this scenario, there was a moment when everything changed dramatically. The universe underwent what we call superinflation. This wasn't just a regular expansion, it was an enormous burst that made the universe stretch out incredibly fast. During this intense period, tiny random changes at the quantum level, which are the smallest changes possible, got blown up into huge differences. These differences laid down the groundwork for everything we can see today, like galaxies, stars, and planets. They started as just tiny ripples in the fabric of the universe, but grew into the massive structures filling the cosmos. Then we have the no-boundary proposal. It's a bit like saying the universe is a kind of balloon that doesn't have an edge you can find. It's round and complete all on its own. In this view, the Big Bang wasn't a point or a sharp explosion, but more like a smooth, gentle phase where the universe was incredibly tiny. This idea suggests that everything we know started from essentially nowhere, a spontaneous burst from what could be called nothing, shaped by the laws of quantum mechanics, which are the rules that govern the tiniest parts of our universe. This theory tries to paint a picture of the universe as a place without start or end, where the beginning of everything we know was just one of many possibilities that could have happened. On top of these mind-bending ideas, scientists, especially those working with the James Webb Space Telescope, continue to dig deeper into how the universe has grown and changed over billions of years. One of their most exciting findings is the spotting of the oldest collection of galaxies ever seen, known as a proto-galaxy cluster, which appeared a mere 650 million years after what we think of as the Big Bang. This discovery is crucial because it gives us a glimpse into the very early stages of the universe's life. Think of the universe as a baby growing up. In the beginning, everything was more or less smooth and even, with matter and energy spread out all over. But just like a child develops features and personality over time, the universe started to change. Tiny differences began to show up. These were the seeds of all the structures we see today. The process didn't happen all at once. It was gradual, with small clumps of matter slowly pulling together to form the stars, galaxies, and other astronomical bodies we can observe now. This growth process is often described as hierarchical, meaning it built up step by step from small to big, much like how a tree grows from a seed into a sapling and then into a full-grown tree. In the grand story of the universe, gravity has played a standout role in shaping everything we see around us. But there's a catch. It can only work as fast as light travels. This means that areas in the universe that were denser than others began pulling in material from their surroundings at a gradual pace, because nothing, not even gravity's influence, can move faster than light. These denser spots, packed with more stuff, started to fold in on themselves over time, turning into the large-scale structures, like groups of galaxies, we can observe today. Imagine a crowd gathering more and more people. That's how these regions grew, but on a cosmic scale. At the same time, on a much smaller scale, massive clouds made up of molecules started to collapse. This process was crucial for the birth of the first stars and clusters of stars. These stars didn't just pop up overnight. It took around 50 to 100 million years for these initial clumps of matter to fall inward under their own gravity, giving us a peek into the very dawn of the universe's history. Now let's talk about the birth of stars. This isn't a quiet, orderly affair. It's more like a wild, unruly process filled with intense radiation and strong winds. These conditions create a hectic environment around newborn stars, making it really tough to pin down their exact shapes and sizes. Despite the chaos, these early stars were like cosmic magnets, pulling in surrounding material and joining together to form the very first large galaxies we know of. These ancient galaxies are fascinating to scientists because they're like the universe's firstborn children. Many of them are massive, filled with a rich mix of heavy elements, and are hotspots for new stars coming to life. They're like bustling cosmic cities, growing and evolving over billions of years. But the story doesn't end here. There's still so much more for us to discover about the universe's youth. And that's where the James Webb Space Telescope, JWST, comes into play. This incredible tool gives us the chance to look further back in time than ever before. While we've already found some of these ancient galactic giants, the JWST might help us uncover even older galaxies and stars, ones that existed even closer to the beginning of everything. This could open up new chapters in our understanding of the universe, offering insights into how the very first stars and galaxies formed and evolved. The hope is that with our massive telescope, we'll unlock secrets of the cosmic dawn, shedding light on the infant universe and its first moments of starlight. Next, we go deeper into space, learning how groups of galaxies form and change what we know about space, the unprecedented making of star cities. You might think that making something as huge as a galaxy cluster would involve complicated science, but it's actually based on three straightforward ideas: how quickly the universe is stretching out, how clumpy things were at the beginning in different spots, and how fast gravity pulled things together over time. The complex stuff happening inside a galaxy, like stars forming or black holes growing, doesn't really affect the creation of these massive clusters. Here, gravity is the main player. It's like the big boss that decides how these clusters form and grow. Before we had the amazing James Webb Space Telescope to show us the wonders of space, astronomers had their own tricks to map out the history and layout of galaxies far and wide. One of the simplest methods was to find a bunch of galaxies hanging out together in the same part of the sky. If these galaxies seem to be moving away from us at about the same speed, something we can tell from the way their light stretches out, or what scientists call redshift, but we're all darting around each other really fast, then bam, we've spotted a galaxy cluster. This approach helped us discover well-known clusters like the Coma Cluster and the Virgo Cluster, which are relatively close to us in cosmic terms. But wait, there's more! Astronomers also had another cool technique up their sleeves. They looked for groups of galaxies that were super hot because of all the crazy stuff happening inside them, like gas clouds smashing into each other or new stars lighting up. This heat makes the cluster glow in X-rays, which special telescopes can see. By studying these X-ray bright clusters, scientists could learn a ton about them, like how heavy they are, what they're made of, and what kind of cosmic smash-ups they've been through. These methods were like cosmic detective work, helping astronomers piece together the story of these giant galaxy gatherings. Each cluster is like a bustling city of galaxies, each with its own history and secrets waiting to be uncovered. And now, with the JWST in the game, we're on the brink of learning even more about these cosmic metropolises. This new telescope lets us peek further back in time and in greater detail, promising to fill in the gaps of our cosmic knowledge. Now let's see an easier explanation of how we've discovered clusters of galaxies in space, which are like big families of galaxies held together by gravity. This discovery process is pretty fascinating because of something called gravitational lensing. This lensing happens when a bunch of galaxies' gravity bends light around them. It's like looking through a weird glass lens that distorts what you see behind it. This effect helps scientists tell the difference between a single galaxy and a whole bunch of galaxies living together in a cluster, kind of like spotting a crowd of people instead of just one person from far away. There's this stuff called intracluster matter, which is basically all the stuff floating around between the galaxies. And it helps with this lensing effect too. For example, there's this galaxy cluster named CLJ 1020 that's pretty close to us in space terms. It's a big family of 17 galaxies, most of which are these super bright, young galaxies called starburst galaxies. They're called that because they're making stars like crazy. This cluster is so old, it's been around for 2.7 billion years since the universe started with the Big Bang. But here's the thing, galaxy clusters like CLJ 1020 didn't just pop up out of nowhere fully made. They had to grow up, just like everything else. Before they were big clusters, they were like baby clusters, or what scientists call protoclusters. These baby clusters are groups of galaxies that are just starting to hang out together in the same part of space. They're not hot enough to glow in X-ray light, which is one way we can usually find grown-up clusters. Scientists use big telescopes on the ground, like Subaru, Keck, and Gemini, to find these baby galaxy groups. They found a couple of these protoclusters that are really far away. One of them has 44 galaxies and is about 1.1 billion years old, which is like looking back in time because it's so far away. Another one has 12 galaxies and is even younger, at about 800 million years old after the Big Bang. These groups are slowly coming together under the pull of their own gravity, getting ready to become full-fledged clusters. And here's the exciting part. The James Webb Space Telescope, with its amazing ability to see far into space, is going to help us find even older and farther away clusters. We're talking about going back to times we've never seen before, getting closer to the beginning of everything. Let's use a powerful space telescope to look far back in time and uncover how the first big groups of stars and galaxies began. Space puzzles. Finding the first galaxy families recently, the James Webb Space Telescope has carried out 3 different studies named JADES, GLASS, and SEERS. These studies have provided new information about the early universe, shortly after the Big Bang. Starting with the SEERS survey, researchers found 4 galaxies grouped together in a tiny part of the sky. They are all located at a distance indicated by a redshift value of 4.9. This group forms what is called a protocluster and is believed to have formed around 1.2 billion years after the Big Bang occurred. This discovery is significant because it helps us understand how galaxies started to cluster together in the early universe. Then we move to the GLASS survey, which is particularly interesting because it looks through a space phenomenon caused by a massive cluster of galaxies known as AEL 2744. This cluster acts like a giant magnifying glass, allowing us to see farther into the universe. Thanks to this natural magnification, the GLASS survey discovered 7 unique galaxies in the same area, all at a greater distance with a redshift of 7.8. This means these galaxies were from a time only 650 million years after the Big Bang, making them part of the earliest known protocluster of galaxies. This is a groundbreaking discovery because it takes us closer to the time of the Big Bang than ever before. The name given to this cluster, a 2744 Z7P90, tells us several things. It was found using the lensing effects of the Abell 2744 galaxy cluster. It has a redshift of 7.9, and it's a significant find in our quest to understand the early universe. The findings from the GLASS field highlight how crucial it is to find and confirm the existence of these distant galaxies. When we identify and study these early clusters, we learn more about how galaxies formed and clustered together in the universe's infancy. This is key to piecing together the vast cosmic puzzle of our universe's origins and evolution. The James Webb Space Telescope has been looking deep into space and has found some fascinating things. Among these are groups of galaxies, some of which form something called a protocluster. A protocluster is like a baby version of the huge galaxy clusters we see in the universe today. However, not all the James Webb spotted galaxies are part of this particular baby cluster. Plus, there are some galaxies out there that we still don't know much about because we haven't been able to get a detailed look at their light. This is what scientists mean when they talk about not having the spectra. Despite these challenges, scientists must keep watching these galaxies. They're trying to figure out how heavy the protocluster is and how quickly the galaxies inside it are moving around. It's like trying to understand how a whirlpool of stars and galaxies behaves. They've been working really hard, and their efforts have paid off with some pretty amazing findings. One of the big discoveries is about how much all the galaxies in the protocluster weigh combined. They found out that the total weight is similar to 400 million of our suns. That's almost the same as the total weight of all the stars, planets, and other stuff in our own Milky Way galaxy. This comparison helps scientists get a better idea of the minimum size and weight of the protocluster. Now let's think about what this means over time. These early galaxies, which are part of the protocluster, have been around for a long time. Since they first formed, they should have grown a lot. Imagine a tiny seed growing into a huge tree. That's the kind of growth we're talking about. In fact, by now this protocluster could have grown about 5,000 times bigger than it originally was. It might even be as big as something called the Coma Cluster, which is a gigantic group of galaxies that we can see today. The James Webb Space Telescope has brought us some exciting news again, uncovering yet another phenomenal finding that has left experts around the world amazed. This time, the telescope has spotted a tiny, ancient galaxy that is rapidly creating new stars. This small galaxy might help us unlock secrets about the early universe's dark ages. During this period, the cosmos was mainly composed of hydrogen gas and was very dim, with hardly any light. The galaxy that the James Webb Space Telescope has observed is named RxJ 2129 Z95. It hails from an era roughly 500 million years post the Big Bang. The reason we can observe this galaxy as it existed back then is due to its significant redshift value of 951. This number helps us understand the vast expanse of time we're peering back through, approximately 500 million years following the dawn of the universe. The discovery stands out even more because despite the galaxy's considerable distance from us, we can still view it. This visibility is thanks to the light from the galaxy being amplified by a massive collection of galaxies situated between us and RxJ 2129 Z95. This collection, known as the RxJ 2129 6+05 galaxy cluster, boasts an enormous combined mass equal to 150 trillion of our suns. It functions as a cosmic magnifying glass, enhancing the light from the distant galaxy, which allows us to see it brighter and split into 3 distinct images for our observation. This extraordinary event provides us with a clearer picture of a time in the universe far removed from our own, offering clues into how the universe evolved from its earliest, darkest periods into the cosmos full of stars and galaxies we know today. Join us as we zoom in on a very old and important galaxy that changes our ideas about how the universe first started shining. Stars on Speed, the little galaxy that's lighting up history. Let's dive deeper into the James Webb Space Telescope's incredible discoveries about a far-off and ancient galaxy we call RxJ 2129 Z95. This special tool has helped scientists figure out exactly how far away RxJ 2129 Z95 is from Earth. This distance is indicated by something called redshift, which is a way of measuring how much the universe has expanded since the light left the galaxy. But there's more to this story. The NSPEC instrument has also detected strong signals from clouds filled with hydrogen and oxygen gas within RxJ 2129 Z95. These aren't ordinary clouds like the ones we have on Earth. These are cosmic clouds teeming with activity and are a key reason why this galaxy is grabbing scientists' attention. As researchers examine the galaxy's light more closely, they uncovered some incredible facts. Although RxJ 2129 Z95 is quite small, it's bustling with action. To help you understand the size difference, let's compare it to something familiar. Think of RxJ 2129 Z95 as a tiny marble and our Milky Way galaxy as a vast stadium. Yes, the Milky Way stretches about 100,000 light-years from one side to the other, while RxJ 2129 Z95 spans merely 105.6 light-years. It's a stark contrast, like comparing a tiny dot to a colossal circle. Now let's put this into perspective. Despite its tiny size, RxJ 2129 Z95 is incredibly lively. It's like finding a small room filled with as much activity and energy as a whole bustling city. This galaxy, despite being only a fraction of the size of the Milky Way, is a hub of star formation. It's producing new stars at a rate comparable to our own galaxy. Imagine that, a space so small, packed with as many new stars being born as the vast expanse of the Milky Way. But don't let its size fool you. This little galaxy is forming new stars at the same rate as the Milky Way. That's like if our small pebble was as heavy as a large mountain. This makes RxJ 2129 Z95 incredibly special and interesting. The James Webb Space Telescope is showing us that many galaxies from the early universe were creating stars at a high rate. But RxJ 2129 Z95 is exceptional even among these. It is much smaller than other galaxies we know from that time, which means it is fitting a huge amount of star making into a very small space. This is a lot like having a tiny kitchen, but cooking a feast that fills an entire house. In RxJ 2129 Z95's case, the feast is the creation of new stars. Despite its compact size, the galaxy is bustling with the birth of stars, making it a standout even in the crowded and busy universe of the distant past. This discovery is significant because it challenges what we thought we knew about how galaxies form and grow. It tells us that even the tiniest galaxies can have a major impact, creating stars at an astonishing rate. This is a crucial piece of the puzzle in understanding the early universe and how the first galaxies came to be. This exciting find backs up a theory called hierarchical galaxy formation. This idea suggests that the universe started off with lots of small galaxies. Over time, these little galaxies combined, like building blocks, to form the larger galaxies we see today. What's really interesting is that in this small galaxy, RxJ 2129 Z95, which the James Webb Space Telescope has been studying, scientists haven't found any signs of a supermassive black hole at its center. Usually, big galaxies have these giant black holes, but not this little one. This detail is crucial, especially when we think about a time in the universe's history known as the Cosmic Dark Ages. This was a period when the universe was filled with clouds of hydrogen gas that were not yet lit up by stars. Eventually, something happened that caused this gas to light up, a process called ionization. But scientists are still trying to figure out exactly what caused this. There are two main guesses. Either it was light from black holes or light from new stars. The fact that RxJ 2129 Z95 doesn't seem to have a black hole, but is still bursting with new stars gives us a hint. It suggests that maybe it was the light from new bright stars that ended the Dark Ages, not the black holes. But to be sure, scientists need to measure just how much light capable of causing ionization is coming from this galaxy. This discovery is just the beginning. If there are more small galaxies like RxJ 2129 Z95 out there, they could have played a big part in this process of lighting up the universe. To understand the whole story, astronomers need to look at more galaxies that are as far away, which also means as old, as RxJ 2129 Z95. This means astronomers are on the verge of possibly solving one of the big mysteries of the universe: how the cosmic dark ages ended. As the JWST continues its mission, each new galaxy observed at these great distances could add a piece to the puzzle. Did the James Webb Telescope show us what was before the Big Bang? Or is there more to find in space? Like and subscribe for more discoveries.